Okay, so here we are. This is homework. It was the first written homework assignment. I can't remember if it's 1 or 2. I've got different file names for it. But anyway, I'll get the right file name for the, for when I post this video. Anyway, so here's the problem. We're going to determine the resultant of adding these two vectors. Okay, so we're going to add A, which looks kind of stupid. Some reason it got, off there, and B, and we're going to try to get, we're going to add them using quote unquote the triangle method, and then using components. Okay, and then what we're going to do is we're going to check to see if these two fit together. Okay, so I'm actually going to do this as if I was working on a sheet of engineering paper, so that you can just kind of understand the process here. So we would start by saying, well, this is homework number 1 or 2. I'm not really sure. I think on my key I put 1, so we'll leave it as that. And then the class, well, this is statics, so this is ENCE 2350 or whatever. And then we're going to put my name, which is Richard Wagner. Okay. Well, since I prefer to go by Wayne, we'll make it Richard Wayne Wagner. And this is page 1 out of, I don't know how many pages we're going to do, so we'll leave that open for now. Okay, so given, we know that I've got a vector. I've got 14 newtons. I'm sorry, this is vector A equals 14 newtons at an angle of 293 degrees. And I've got B, which is 17 newtons at an angle of 147 degrees. Okay, I mean, obviously those are some sloppy angles. In this case, the reason I gave you those angles is because, this symbol, when typing, is really the only one I can use. So I have to start from positive x. So I have to give you an angle. I didn't want to just give you like 30 and 72, because then those are all in the first quadrant. And then, what happens if I give you something different on an exam? Okay, required. So we want to know, we want to know what is the resultant of A plus B using the triangle method. Okay, and then B, we want to know the resultant equals A plus B. Okay, using the component method. And then C, it didn't really say C, but, confirm that R from A is the same as R from B. Okay, now explicitly says that to take B, your answer from B, and turn it into polar notation, but whatever. All right, so here's our solution. Okay, so we're going to start. I'm going to draw this because that's just, A, it's good practice, and B, I think in this case, it should help a lot. Okay, so I'm going to start by getting a pencil tool, and so here's an axis. Okay. Now, as you can tell, I've got my ruler out, so you probably hear it slapping around as I, pick it up and whatnot. So here's X, here's Y. Okay, hopefully those will show up on your screen. And we'll start with A. So it's 14 newtons at 293 degrees. So this is 90 degrees. This is 180. Here's 270. So I'm going to go another 23 degrees, and I'm going to draw A. And I guess I'll make A in blue. So, I wanted this with a pen, though. Let's give it a pen color. Okay, so here's A. Okay, and let's see, 14. So we'll do almost 3 centimeters, but not quite. Okay, so there you go. So that's more or less 14 newtons. And that little angle right in there, if I go back to the pencil, this little angle right here, that's 23 degrees. Okay, 20, let's zoom in here. Give me my hand here. Oh no, don't do that. That's not what we want at all. Okay, let's put that back. Okay, let's zoom in over here. This is just sloppy, right? So we want 20, come on, you can do it. 23 degrees. Okay, so now we got our 14. Okay, so that's A. B, 147 degrees. Okay, let's make B, let's do red. Okay, so we're going to go 90 to here. Let's see if we can zoom in again. Will you let me zoom in, you punk? Okay, zoom in. Okay, so we're going to go 90 to, come on. Okay, So we're going to go 90 to here. Okay, and then we're going to go another, what, 57 degrees, I believe? 57, yeah. Well, you know what? We're not going to draw that one from there, are we? Sorry. All right, so we're going to start here at this this intersection here. All right, we're going to go here, and then we're going to draw this going here. Okay, and that way I can figure out where this degree is, right? So what we're going to do is I'm going to start. So this is the tip to tail, right? So I'm going to start my tail at the tip of that one. And so we need 147 degrees. So we're going to start at 0 to 90. And then that leaves another 57 degrees. So we're going to go another 57 degrees. Okay, so that's somewhere past 45. Okay, and we'll do that in red, I guess. A red pen. Okay, and so it should be a midge longer than this 14. Okay, so we'll make it a midge longer than that 14. Okay, so maybe it's obviously not going to be perfect. Okay, I forgot what point I was going to. That's pretty good. There we go. Tip to tail. Okay, so this right here, if we let's see, this is 17 newtons. Okay. And its angle, if I do it in red pencil, where's my pencil here? Here's my pencil. Okay, its angle right here, well, that's 57 degrees. 57 degrees. Okay? Now, the resultant, which we're looking for, we'll make that, I guess, green. So this is the resultant right here. Nope, we want green pen. Excuse me. Let's get some pen here. Okay, so here's the resultant. That's in green pen. And the angle we're going to want is this angle right here. Okay, so that angle is not inside the triangle. Okay, now let's go back to kind of what we know. So we know 57 degrees is from here to here. Okay, that 23 right here, which is right here, I'm going to say based on that 23 that this one right here is also 23. Okay, now remember, what I'm looking for is I'm looking for angles inside the triangle, right? So so what I want, sorry, let me back up a little bit. What I want to work with is I want to work with this angle, or this angle. Okay, those are the angles inside the triangle, right? I don't have any of those, or at least I didn't a second ago, but I'm about to have one, right? So, so the first thing I do is I say, okay, well, this is 23 degrees. Okay, so that makes this one 23 degrees. Which means that, let's see, this 23, and then there's a 57 right here. So the difference between those two is going to be this angle right here. Okay, so 57 minus 23 going to give me 34 degrees. Okay, that's something I can work with. Okay, so once we get there, we go, okay, well, that's cool. Now I've got one of those things that I hope you remember that you wanted, which you wanted side, angle, side. Okay, because if you have that, you could do the law of cosines. So here's the law of cosines. Law of cosines. Okay, and so we're going to do, so basically it generally looks like this. C squared equals a squared plus b squared minus 2ab cosine of gamma. Okay, noting that c and gamma are across from each other, and A and B surround gamma, okay? So A, gamma, B, and that's going to give us side C, which in this case, of course, we won't use C. We will use, we'll use R, okay? And so, so over here, because it's the resultant we're looking for, we're just going to call that the resultant, okay? So at this point, this is now an algebra problem. We're just going to kind of plug things in. So I'm going to say, okay, well, the resultant equals. I'm going to take a square root of both sides. So I'm just going to kind of put a bracket here. So a squared is 14 newtons squared. Let me zoom in here. I guess I should leave my image there too. Come on, don't freeze on me. Okay, you're being a jerk. All right, so 14 newtons squared plus 17 newtons squared. minus 2 times 14 newtons times 17 newtons times the cosine of that angle, which is 34 degrees. Okay, and we're going to take the square root of that. So we're going to bring that all to the 1/2 power. Okay, if we plug all that into our calculator, we'll get the result, or the magnitude of the resultant is 9.5067 newtons. Okay, we're keeping 5 sig figs all the way through because it's going to make our lives better, okay, or it's going to make our answer a little bit better. All right, so as I mentioned to you guys in class, this is an interesting one because gamma here, not gamma, this angle right here is going to end up being close to 90. So when we do the law of sines in a second, that's going to get a little bit funky, okay? Anyway, so usually what we want is at this point, we've got the resultant. We know how long the resultant is. So what we're going to work on now is we want to get this angle. We're trying to get this angle right here. And the best way to get that angle is to know this angle right here, okay? So to get that angle, we're going to do the law of sines. Is the kind of the standard way to do this. And we're going to talk about why this is maybe not perfect in this case. But the law of sines looks like this, okay? The sine of, let's do beta over b, okay, equals the sine of gamma over r. Okay, now how did I choose those letters? Well, what I did is I said, okay, this right here is b, so the angle across from it is beta. Okay, so that's this guy right here, right? And then what I'm working with though is I'm working with well, the only other angle I know is this one. So that means that's gamma and it's across from r. Okay, so that's this one right here. Okay, so that's kind of how I decided to do it that way. All right, so then we just need to kind of plug in what we got here, which is going to be the sine of beta. Let's see, beta, that's the angle we're looking for, over b. B is 17 newtons, equals the sine of gamma, sine of 34 degrees, over the magnitude of the resultant, which is 9.5067. Okay, and right there you see why we kept the 5 sig figs, because if we had rounded before that, it would have created an error here. Okay, now obviously there's still an error. We rounded to get that 9.5067, but there really shouldn't be an error. Okay, so algebraically, I'm going to go ahead and work this one out because I think that will be helpful for some of you guys. So what we're going to do here is I'm going to say the sine of beta equals, this becomes 17 newtons times the sine of 34 degrees. Okay, make sure your calculator's in degrees, times 9.5067 newtons. Okay, so when I plug that into a calculator, I'm going to get the sine of beta equals, okay, this number is 0.99996, okay, which is a horrible number, right? So in order to get beta by itself, what we need to do is we need to take the inverse sine of both sides. Okay, so that's how you get rid of the sine. So we get the inverse sine of 0.99996. Now, normally I don't recommend even writing this down. You just kind of leave it in your calculator. That way you're keeping like not just the 9 or 8 or 9 sig figs that they show you, but all the ones they don't show you too. Okay, so when we take the inverse sine of that number, we get something that is kind of problematic. Okay, so we get beta equals 89.461 degrees. Okay, now this is problematic, okay, because, I didn't mean to do this, but I want to, give you a little flashback to the unit circle over here. Okay, so here's the unit circle, more or less. Okay, and it looks like this, and it looks like this. Okay, and so if I take just some random angle right here, okay, then if this is a 1, then this has the coordinate cosine of theta, sine of theta, right? So when I take the inverse sine of some kind of number, okay, so what I'm saying here is what angles have this as their essentially as their y component on this circle. Okay, so what I want to note here is that in this in this drawing that I have right here, there are two possibilities for that angle. Right, one would be right here, theta. Okay, and another one would be right here, right? This one also, this one has it's got a negative value in the x direction, but it's got the exact same value for sine. Okay. And so there's two angles that can give us that answer, right? So one of them is, over here, and one of them is over here. Okay? And what's important about them is they're both equidistant from 90. Okay? So in other words, what I need to do here in order to figure out what the other possibility here is, I just need to, okay, so what I'm going to do is I'm going to figure out how far is this thing from 90. So if I do 90 minus that thing, then this is essentially 90 minus 0.538, 0.539 really, I guess. Okay? So then the other possibility for beta is 90 plus that value. So it's going to be 90.539 degrees. Okay? Now, this is problematic because it's kind of like, well, how do we figure out which one of those is the correct answer? Now, normally on a normal problem, it would be obvious because you would get to this point and you would have gotten a number, and let's suppose this is 30, and then this one is, what is that, 150. Well, then, by looking at your initial problem up here, you would just be able to kind of look at the angle, and based on your drawing, you'd be able to say, well, it's either 30 or 150. Those are very different. But in this case, they're close to a right angle. Okay, it's not a right angle, but it is close to a right angle. So that makes this very difficult to kind of just mentally imagine. So there isn't really a good way to get at, and again, I didn't do this on purpose, but it was it's a good reminder of the way sines and cosines work. So what you need to do in this case, I would think, would be you go back to this diagram here. And what I would do is this, okay, and I think that this is probably your best bet. One of your classmates did this by using the law of cosines twice, and they just kind of did it. I'm not sure what angle they did it on. I think they ended up making a mistake. But what I would do is if this angle ends up being close to 90, and you're kind of like, I can't tell which side of 90 it's on, well, then do the law of sines for this angle, okay? So let's go ahead and do that. So now we got the 14 with alpha. So the sine of alpha, so that we're going to call this alpha, over A, 14 newtons, equals, now we're still going to work with the angle that we know, okay, the sine of 34 degrees over the resultant, which was 9.5067, 9.5067 newtons. Okay. If we do that, the nice thing here is with this angle, okay, if I've done a good job drawing, is I can tell that thing is less than 90. Okay, so I don't have to stress too much. The inverse sine is always going to kick out basically two answers. I mean, your calculator is only going to kick out one, but there's the other possibility. But in this case, if I do, I know it's going to be less than 90, so whatever the calculator kicks out, I should feel pretty good about it. Okay, so this, for some reason I switched colors here. Sine of alpha equals 14 newtons times the sine of 34 over 9.5067 newtons. Okay, so then alpha equals the inverse sine of 14 newtons sine 34 over 9.5067 newtons. Okay, and if we plug that into the calculator, we get 55.436 degrees. Okay? So you're kind of like, well, that's great, but the whole point of all this is that we wanted this R angle right here, and that doesn't really help us there, except that it does. Okay, so so if I put this on this diagram, 55.436 degrees. So really what I want is I want this angle over here. Okay, so what I'm going to do is I'm going to make note of the fact that those three angles have to add up to 180, right? So I know that 34 degrees plus 55.436 degrees plus whatever that angle there is, which I think we're calling beta, plus beta equals 180 degrees. Okay, so if you do it that way, you could say, okay, well, 180 degrees, let's see, we end up with, we end up with a number like 90.564 degrees. Okay, so if we go back over here, where is it? 90, well, that's weird that we're off by so much. Anyway, so we can see that this is the number that we want. Okay, I mean, those numbers should be exact. Obviously, there's some rounding errors going on in here. Anyway, so I'm going to go ahead and use this one because that's the one that I use on my key. But you know, if you'd solved and gotten this one, that would have been fine. Maybe I had a rounding error here. I'm not really too worried about it. But anyway, so beta is 90.539 degrees. Okay, so let's go back up to our drawing, which is getting very annoying and ugly, right? But we're almost to where we want to be. Okay, so let's see. I'm not sure what a good color is here. Let's say blue. Okay, so this right here. Blue is no good. Let's make red. Okay, this right here is 90.539 degrees. Okay, so what I'm going to do is I'm going to subtract off this 23 right here. Okay, so 90.539, and I'm going to subtract off that 23. Okay, and that gives me this number 67. So that means from here to here is 67.539 degrees. Okay. Now I will note then, if I use my green here, that this from here to there is 90 degrees. So from here to here is 67.539. Then what I can do is I can subtract that number out of 90, and I'll get 22.461 degrees for R. Okay, so that angle, which I guess we'll call that theta, is 22.461. Okay, so we'll say, theta, you know, after all of this nonsense, right, say theta equals 22.461 degrees. Okay, so we'll put a black box around that. And basically I want to combine these two answers, these two black boxes here. And I can say that the resultant, okay, now I'm going to put the arrow on it. Up here was just the magnitude, over here it's the vector, is 9.51, okay, newtons, at an angle. Now we need to remember that this angle is being measured relative to the negative x axis. And we're going this way, right? 22.4 or 22.5. So we'll go ahead and say relative to the negative x direction, I'm going to turn that way, which is counterclockwise. And this is going to be 22.5 degrees. Okay, and that is the answer. Okay, that's the answer to part A. Okay. I guess I could show you how I'm grading this. Well, I would grade that three ways. I'd be looking for, you get a point here, you'd get a point here, and you get a point for reporting it correctly. Okay, and those obviously, that's obviously the points that you would lose, would be not doing those. You're also going to get a point for putting all your givens, putting all your requireds. Okay. Anyway, so let's call that page 1. Okay, because that was pretty hefty. Let's go ahead and do page 2 for part B. Okay, so let me get this thing out. Part B. Okay, so again, we're imagining we're working on engineering paper here. So this is homework 1. This is the class statics. This is R. Wayne Wagner. There's an A in there. And there's this is page 2 out of probably 2 pages, but I guess we'll see. All right, so now we're going to do the components. Okay, so this is part B. I'm going to do this by components. Okay, so again, I'm going to draw this because it helps me organize. I kind of recommend that you do too. All right, I might even make you draw it. Who knows? All right, so anyway, so here's my coordinate axis. Boom. All right, so we've got a y-axis. Now here's an x-axis. Okay. All right, x. And y. Y, come on, you can do it. Okay, there's y. All right, so now let's see here. A, we'll make 14. Now, we've already figured out these angles, so I'm not going to belabor that point here. I want to make this in pen, though, don't I? Let's give me that pen. Okay, so here we go. Okay, so this is going to be, that's 23 degrees. Okay, and that was 14 newtons. Okay, and then we'll do B, which we'll do in red. Okay, and red looks like this. Let's see, how do we do it? I don't know, maybe it's in here somewhere. Right? Okay, and this one's 17 newtons. Okay, and it's got an angle here. It looks like in my key, for some reason, I used 33 here. You could have, if you wanted to, use 57 right here. But for some reason in my key, I used 33 degrees. It's not critical. Okay. Anyway, just to make note, so what we're looking for B is we're going to look for B in the X and B in the Y. Okay, and for A, sorry, it looked like I just hit pause on accident. It's going to go down to here, and so that's AY, and here's AX. Okay, you could just as well have drawn a triangle over here if you'd wanted to. I just chose not to. Okay, obviously that would be a different angle unless you wanted to use the 23 here or the 67 there. But you know, that's up to you. All right, so anyway, so we need to get those sides of those triangles. So we'll start with A, and I'll do A in, you know, so here's A. A equals. Okay, so here's A. Okay, so now, so if this side is the magnitude of A, okay, sorry, if this side is the magnitude, right? And then this side then is the adjacent to that angle, that 23, and this side is the opposite to that 23. Okay, so with A, what I can do is I can say, well, okay, I know my trig. I'm good at trig. So here's a triangle. I've got 14. I've got an adjacent over here, ADJ, right? So I say that means I need a cosine. So cosine theta equals adjacent over the hypotenuse, right? Okay, in this case, this is for the 23 degree angle. Okay, so I can say, oh, okay, so, sorry, the cosine of that 23, come on, that 23 degree angle looks like that. So then the adjacent equals 14 cosine 23. Okay, and I could say similarly, I can say the sine of that 23. Okay, this is the opposite. So sine, so is the opposite over the hypotenuse, right? So then the opposite is 14 sine of 23. Okay, and so that's basically how we figure out what those sides are, right? This opposite in this case, that is A and the X, and this adjacent, that's A and the Y. Okay, so that's basically how we're splitting this apart, okay? So I'm going to go up here, and I'll note that A and the X is right here, and we're going to say, well, look, it's going in the positive X direction. So for A, we're going to get 14 newtons times the sine of 23. Sine of 23 degrees. Okay, and that's in the I direction. And then for the Y direction, we'll note that, oh, look, it's going down, so that's a negative minus 14 newtons times the cosine of 23 degrees, and that's in the J. Okay, now we're going to go ahead and do B. B equals, now notice we've got the same things going on here. The only difference for this triangle is that, let's see, this is the adjacent is in the X direction, and this is the opposite in the Y direction. Okay, so we can go up here for beta, and I can say, okay, well, let's see. So that means that we've got 17 newtons, 17 newtons, 17 newtons. Okay, which one of these is the adjacent? This is the adjacent, so the X direction is going to get the cosine. Okay, and the Y direction is going to get the opposite. So that's going to be sine of 33 degrees. Okay, here's a j, here's an I, and now we need to check signs. Okay, we're going negative in the x direction, and we're going up in the y direction. So there you go. Okay. Now to solve this at this point, there's just a certain amount of calculator work, and I'm actually going to work sideways here in black, just because it's just going to be, I don't know, I like to keep things lined up if I can. Okay. The other thing I'm going to do is I'm going to move my newtons out front, just because I'm going to it's just a way to keep the units, keep my numbers kind of easy. So what I'm going to do is I'm going to plug these things into the calculator. So 14 sine of 23 is 5.4702. And in the j, we're going to get negative. So 14 cosine 23 is negative 12.887. Okay, and so similarly, I'm going to get some numbers here. And it's going to be 14.27257, excuse me. And 9.2589, 2589. Okay, so since I'm adding the two of these, that's going to give me my resultant. So I'm going to draw a line right here. I'm going to draw a single line right there. I'm going to say the resultant is if I add all of these things up. Okay, so if I add, I get negative 8.7868, keeping 5 sig figs. Okay, minus 3.6281 in the j. Okay, and we're going to go ahead and put newtons there. Okay, so this is an intermediate step in this is a solution, but it's not usually the solution we want. Almost always when you're looking for an answer in components, you almost always want to convert it back to polar, because this is not very meaningful. However, if we want to check to see if this is reasonable, we've got basically a negative 9 and a negative 3.5. Okay, so let's go back over here to the first part. Okay, could this be conceivably negative 9 in the x direction and negative 3.5 in the y? Okay, it seems like that could be. Like, obviously my drawing's not perfect, but it seems like a very real possibility. Okay, or better yet, let's go back to, where's my work? Here it is. Let's go back to this one. Okay, and let's take these numbers right here and put them on this diagram. Okay, so A, let's see here. So this number, well, let's erase some of this business that's kind of just muddying the waters, as it were. Okay, so let's go ahead and put some blue numbers on there and some red numbers on there, and hopefully we can make this make some sense. So in the x direction, I've got 5.4. Just because we're just trying to get a general idea, 5.47. And this is 12.9. Okay, and then for the red, I've got 14.3. Again, we're just trying to, don't worry about all the sig figs. I'm just checking to see if this seems reasonable. 9.3. Okay, so let's imagine now you went 12.9 down, and then you came back up 9.3. Okay, the net would probably be about, if you added those two up, would be, about 3.5, 3.6 down, right? Okay, now on the other hand, let's try the x direction. You went 14.3 to the left, and you came back 5.5. Okay, so 9, maybe almost 9, right? So almost 9 in this direction, right? So maybe 8.9 or whatever. Okay, so totally reasonable answer. Okay. Anyway, so let's go ahead and let's solve this all the way. Let's get this into polar coordinates so we can figure out if this matches the first bit. Okay, so to get this into polar coordinates, we're going to say, well, r equals the square root. Well, let's draw this out, since this is like a pretty intricate solution. We might as well do it 100% correctly all the way to the end. So let's go over here. Let's draw a little, our little axis here. Okay. Okay, that's the y-axis, and here's the x. I've been noticing lately, I draw the y's before I draw the x's. I don't know if there's a reason for that or not. Okay, x. All right, so what we're going to do is, I'm going to do this in blue so it shows up. is I'm going to go negative 8.78. Let me zoom in here. Okay, so I'm going to go 3 of these squares, basically. Negative 8.78, so it's about right there in the x direction. And then negative 3.6 in the y direction. So that's, image more than one of these. So we're going to go like that. Okay? And so what we're looking at for the resultant is going to be this thing right here. Okay? So we're looking for this angle, and we're looking for that magnitude. Okay? So here's the resultant, and here's the angle theta. Okay? And on here we've got 3.6281, excuse me. 6281, and in the vertical, 8.7868. 8.7868. Okay, boom. All right, so to get R, well, we're going to want to do the Pythagorean theorem, right? So we'll say, okay, well, R equals the square root of the two sides, right? A squared plus B squared equals C squared. So 8.7868. In this case, these are newtons squared, so this should actually have newtons on it and newtons on it, plus 3.6281 newtons. Okay, noting we're not worried about the fact that these are negative or anything like that because it's all being squared, right? So if we plug that into a calculator, we'll get 9.5064 newtons, which I think you should note that's pretty close to what we had earlier. And then we have to get the angle here, okay? And so to get that angle, we always need to remember SOHCAHTOA. So in this case, TOA, that means opposite and adjacent. Okay, so we'll say tangent of theta equals the opposite, 8.7868 newtons, over the adjacent, which is 3.6281 newtons. Okay, so theta equals the inverse tangent of that quantity, 8.7868 newtons, divided by 3.6281 newtons. Okay, and if you plug that into the calculator, we get theta equals 22.436 degrees. Okay? So then we could say, okay, and the last thing we want to remember is, okay, so we want to remember to go ahead and combine these two, and we'd say that R equals 9.51 newtons at an angle. Now notice this angle again. It's being measured from negative x. Okay, it's being measured counterclockwise from that. And it's 22.4 degrees. Okay, 22.4 degrees. Okay, and so the last thing that we needed to do, so that's part B. Okay, and the last thing we needed to do for part B is compare to see whether or not that is the same as this, right? And of course it is in this case. So we'll go way back over here and we'll say, check, it's the same, okay? That was worth a point. Okay, so the other two things that were worth a point was this right here and this right here, and then converting it into polar, okay? Noting that I don't double count errors, so if you got here and you were like, these are different, but I don't know why, because for some reason you got a different answer, okay, then I would have given you that point. That's fine. Like I mean, obviously we don't want to get that answer. It means something was wrong, but it's okay. I wanted you to know that you should be getting the same answer, okay? So that's where all 9 points on this come from. So, well, obviously you don't get points for same and different, but ideally you got that they were the same. So this is 1, 2, 3, 4. Let's see here. Where are we? Okay, here we go. 5, 6, 7, 8, 9. Okay, so you could have gotten a 9 out of 9. Okay, and that's it. Oh, and then because this was 2 pages, you would put a 2 right here, and you go over here, and you would put a 2 right here. And what does that do? That helps me figure out, if a page goes missing, it means I can go find it. Okay, that's kind of the reason for that. Okay, so that's the answers. Obviously, this is longer. That's 40 minutes. Hopefully you can do this quicker than that. But obviously you got to practice. So anyway, thanks guys. Take care of yourself. Remember, You yourself are way more important than any of this stuff. So let me know if I can help you, whether that be personal or academic or down the road professional. So anyway, take care of yourselves. Okay.